So although the unit of electromotive force is the same as potential difference, it is not the usual potential difference 啊，就是说电动势它的单位虽然跟电位差一样，但是它跟一般所谓电位差的概念其实不一样啊。电位差是保守力才有的，好，那但是呢，这个电动势呢，它是可以跟电位差混在一起，在电路中使用，但是它本质上不是一个电位差啊。原因是什么呢？原因是这样子啊。如果我考虑的是，if I consider electrostatics, then I have curl E equal to 0, and in this case, this equation implies that E can be written as minus gradient V. Here V is the potential. So if this equation is correct, then I will find this consequence. Okay. However, in electrodynamics, in electrodynamics, curl E is not equal to 0 but equal to minus time rate of change of B. So this I can only get this result here. B is equal to curl A. A is the vector potential. A 是 vector potential， 就是所谓的向量式啊，向量式。好，那这个式子是来自于什么呢？刚刚不是 divergence B 等于0吗？没有 monopole， divergence B 等于0。那什么样的东西的 divergence 等于0？就是 curl。好，就是我们在公数里面我们学到一个向量场的旋度的散度是0，所以 B 就写成一个旋度。好。In engineering mathematics class, we learned that divergence curl some vector field is equal to 0. Okay? 旋度的散度是0。Now we have divergence B equal to 0, so we can guess that B can be written as curl of something. This something is called vector potential. Okay? So if we apply B equal to curl A to this equation, we get this equation. Now, we also learned from engineering mathematics that curl of gradient something is equal to 0. Okay? 就梯度的旋度是0。So this term can be written as minus gradient V. So in electrodynamics, E is equal to minus gradient V minus partial T partial A. Okay? So this is different from this electrostatics result. Okay? In electrostatics, E is always equal to minus gradient V. And in electrodynamics, E is equal to minus gradient V minus partial T partial A. Okay? So, in this situation, V is no longer called potential, but called scalar potential. V is called scalar potential, and A is called vector potential. Okay. So E times Q is no longer a conservative force. Okay. If E is conservative, if Q times E is a conservative force, then we will always get force line integral along a closed loop equal to 0. Okay. However, in this situation, because we have this term, so the line integral is not equal to 0. Okay. So this is the third equation in Maxwell's equations. Now we consider the final equation in Maxwell's equations. The final equation is the Ampere's law. Here the J is in fact the JF. This F means free current density. Free current density. Okay. And originally, Ampere's law was written as curl H equal to J. However, Maxwell found that this original version of Ampere's law leads to some contradiction. A wrong consequence from this is if we take the divergence of both parts in the equation, divergence curl H, according to engineering mathematics, we know this is equal to 0. So this implies that the divergence J is equal to 0. However, this consequence can only apply to static current. 就只有在这个直流电的情况下呢 ，divergence J 等于0，因为它相当于是不可压缩流体。不可压缩流体就是你假设给一个管子你从这个截面进去，跟从另外一个截面出来的通量是一样多这叫不可压缩流体。可是你对电流来讲，这件事是有被违反的可能因为电容器就是电容器，你电容器是可以充电的嘛，代表电荷可以在中间这一段累积，所以你可以进来的通量跟出去的通量不一样。OK， 那如果你要包含让电容器充电这个现象可以被描述的话，这个式子就要被修正，对吧 ？So Maxwell modified the original version of Ampere's law to this form. Use this modified Ampere's law, we can describe the 充电到时候怎么讲？我突然忘记the behavior of capacitor. Okay, without this term, we will not able to describe the correct behavior of capacitors. Okay, 那还有一个重点是这样子 ，without this term, we will not be able to generate electromagnetic wave. Okay, Maxwell found that once we have this corrected Ampere's law combined with the Faraday's induction law, we will get electromagnetic wave. Okay. However, Maxwell did not live long enough to see how to test the existence of electromagnetic wave.